Alright, in this video I'm going to teach you a little trick called synthetic division. And the reason we're learning this is division when we have polynomials. Okay? One polynomial divided by another polynomial. You get all these variables involved and it gets kind of hard to follow the process. I mean, long division is hard enough just with regular numbers to remember. With variables, there's a specific process for it, but it's not the easiest way there is. So we're going to learn a process called synthetic division, and what that does is it eliminates all of these x's from the process, but we have to be very specific in how we set up the numbers that are attached to them. So here's how we do this. Synthetic division starts with a chart. Okay, and in this chart I'm going to put all of the coefficients that are involved in my big polynomial. Okay, so I'm going to take this first polynomial, x cubed minus 5x plus 12, and I'm not going to write any variables. I'm going to write the numbers that go with it. Now here's something to look out for. X cubed has a 1 with it, so that's the first number I put. But as I work my way down the list here, if I'm going this direction, okay, I have x cubed, and then after x cubed, usually we have an x squared, but there's no x squared in this problem. So for synthetic division to work, I have to have kind of a placeholder there. So I'm going to write a 0 because there is no x squared term. And you have to watch out for these gaps that show up sometimes. Now after x squared comes x to the first, and that one happens to have a negative 5. And then comes our constant, which happens to be positive 12. And you don't really need to write the positive, but you can if you want to. Now, what are we going to divide this by? Well, let's look at the little polynomial over here that comes after the division sign. That's x plus 3. You have to do a little bit of interpreting here. What we need to do is we need to figure out what number we can plug in that makes that stuff equal 0. And the answer to that is negative 3. So negative 3 is what we are going to divide by. So now we got this whole process here that has no x's anywhere. Once you get past this point, we don't have any variables left. They're still there, we're just not writing them down, so we'll interpret it at the very end to see what it means. Now, let's take this process and just kind of get used to how it feels. We're always going to start by taking the first number, and every time we move down the chart, we're going to add. Well, there's nothing underneath the 1. There's nothing there. There's really a 0. 0 means nothing, so 1 plus 0 is 1. That's how we always start. We basically drop the first number down. And then after that, we take this number out here and we multiply the negative 3 times the 1. And negative 3 times 1 gives me negative 3. So I replace that answer right there. Now I go back to my other step. I'm going to add down. 0 plus negative 3 is negative 3. And now I'm going to take negative 3 times negative 3, put that answer right here, which would be positive 9. And once again, add down. So negative 5 plus 9 happens to give me 4. Now I'm going to take negative 3 times 4, and negative 3 times 4 is negative 12. And when I add those down, I happen to get 0. I have a remainder of 0. Now, if that number wasn't a remainder of 0, it doesn't mean the answer is wrong. There are ways to write that correctly as a remainder. We'll get into that at a later time. But if it does happen to equal 0, then I've gotten a nice value. This stuff up here, whatever I could plug in there to make that equal 0, which in this case was negative 3, that happens to be a root or a solution of this polynomial right there. Now, let's see what all these numbers mean once we get to the end. Okay. This right here has a meaning. It's not just numbers. There are x's there. We just didn't write them in the process. Now, what I want to ask you is, what is the highest exponent we started with? And if you look up here, that was a 3. We started with x cubed. The way synthetic division always works is after you go through one round of it, we went through one round of synthetic division, worked ourselves out, had a remainder of 0, which was nice. The remaining numbers will start with variables that have one exponent lower than our beginning problem. So if our beginning problem started at x cubed, then this problem will start at x squared. And then the next term is x, and the next term is a constant. So these numbers really mean 1x squared minus 3x plus 4. And you might be saying, okay, I've got the process down, but what does this all mean? Remember our original problem. Okay, let's go back to the very original thing we had. X cubed minus 5x plus 12 divided by x plus 3. So I took one polynomial divided by a smaller polynomial, and the answer to that, surprise, surprise, is a polynomial. X squared minus 3x plus 4. In a future video, we'll get into what that answer really does for us when we're trying to solve some large equation that we're not accustomed to doing.